planets being born in knots of dust, an unknown energy propelling the expansion of the universe, shattered comets, and misshapen asteroids, galaxies that crash together to remake themselves, faint, distant glimpses of light from the universe's most distant collections of stars. For more than 25 years, the Hubble Space Telescope has brought the wonder, beauty, and mysteries of the universe to Earth, spinning pictures out of light that have transformed our understanding of the universe. With over 1.5 million observations and counting, Hubble continues to trek above Earth's surface, free of the light-distorting and blocking effects of our planet's atmosphere, beaming home data that reveals the answers to some of our most critical questions about the cosmos. A Space Telescope. Hubble was designed as a general-purpose observatory meant to explore the universe in visible, ultraviolet, and infrared wavelengths. To date, the telescope has studied more than 40,000 cosmic objects, providing views astronomers were unable to capture from the ground. In addition to blocking certain wavelengths of light altogether, Earth's atmosphere is made up of shifting pockets of air that cause the twinkling appearance of stars in the night sky. This motion blurs images captured by telescopes on the ground. Hubble was placed into orbit above the atmosphere to avoid these effects. Though Hubble's mirror is much smaller than those found in the largest ground-based observatories, the telescope's unique position above Earth's atmosphere gives it incredible clarity. As the telescope orbits Earth, its mirror gathers light from the cosmos, collecting images and data. For some of Hubble's deepest images, the telescope has stared at the same point in the sky for days, trying to capture as much of the dim glow of the far universe as possible. When Hubble was launched, the age of the universe was known to be somewhere between 10 to 20 billion years old. By examining a certain class of stars that can be used to define distance, Hubble was able to help narrow that broad figure down to approximately 13.8 billion years, a number now used to understand the timeline and development of stars, galaxies, and more. Hubble has uncovered supermassive black holes lurking in the hearts of galaxies and helped map the presence of elusive dark matter around galaxy clusters. But one of its strangest discoveries was the revelation that the expansion of the universe is speeding up, driven by the presence of a still unidentified and previously unknown dark energy. With its ability to bring pristine images of the universe to Earth, Hubble has often shown humanity how much it has still to learn about the cosmos. Hubble's time machine. Space is so immense that it takes even light considerable time to travel the vast expanses between objects. The light from Earth's moon takes about 1.3 light seconds to reach us, so when we look up at the moon in the sky, we see it as it appeared 1.3 seconds ago. The light of the most distant cosmic objects began traveling through space billions of years ago. When it finally arrives in our corner of the universe, it shows us the universe as it was in the distant past. By capturing the faint light of the early universe, Hubble can see galaxies as they were billions of years ago, showing us how galaxies developed and evolved over time. We can't watch galaxies or stars change. They evolve on a time scale of millions and billions of years. But by viewing them at different stages of their existence, Hubble has helped demonstrate how galaxies change and grow through interactions and collisions. It's given us snapshots of stars at different stages of stellar life and shown them coalescing and igniting in clouds of gas and dust, breathing out outer layers as nebulas, and exploding as supernovae. Planets in near and far. Hubble has been used to probe everything from the weather on planets in our solar system to the birth of planets around other stars. It's examined the composition of the atmospheres of these extrasolar planets, or exoplanets, and may have captured one of the first visible light images of such a planet. Hubble's ringside seat to cosmic events has made it an essential witness to events in our own solar system, such as comet and asteroid impacts on Jupiter, storms and auroras on our neighboring planets, disintegrating asteroids, and passing comets. Our cosmic backyard still holds many surprises, And Hubble has found rings and moons around Uranus and moons around Pluto. Because of Hubble, we have a much better understanding of what our solar system truly looks like and how it works. Science of tomorrow. With a unique design that allowed it to be serviced in orbit by astronauts, Hubble has periodically been repaired and updated with cutting-edge instruments. Now at the pinnacle of its capabilities, Hubble continues to expand the boundaries of our cosmic knowledge. With a history of unparalleled discoveries behind it, more mysteries await to be unraveled, and more revelations are yet to come, each opening our eyes a little further to the wonders that exist in the near and far reaches of the universe, brought to us by a telescope that lifts humanity's vision beyond Earth. Why do they put telescopes in space? Telescopes are placed into orbit around the Earth or are sent farther out into space to get a clearer view of the universe. There are many different types of space telescopes. Some are used to study a special object like the Sun. Others are used to study the different types of light given off by objects in space. X-ray and gamma-ray telescopes study the hottest and most explosive objects in space. Infrared telescopes study the places where stars are born and can look into the centers of galaxies. Optical telescopes study the visible light from space, and ultraviolet telescopes study very hot stars. Many of these types of light, such as X-rays, gamma rays, most ultraviolet, and infrared, can only be studied from space because they are blocked by our atmosphere. What is a space probe? A space probe is an unmanned craft which is sent into space to do research. When we want to get close-up pictures and information about the planets, moons, comets, and asteroids in our solar system, we send out space probes. Space probes can carry special cameras and instruments far out into the solar system. Some space probes study many planets and moons while flying past them. Others go into orbit around a planet or moon to study it more closely. Thanks for watching. Please be sure to subscribe the channel for more space videos.